Hey class, today we're going to learn how to classify a polynomial, as in name it. We're going to learn how to describe its behavior and talk about the number of solutions just by looking at the polynomial itself. So we're going to call this like characteristics of polynomials. So first to classify, I always think of like naming the polynomial. We are going to name the polynomial. It's going to have a first name and a last name, and the first name is going to have to do with the number of terms. And the second name is going to have to be about the degree of the polynomial. So right here, you see that this has 3 terms, and its highest degree is 4. So this is how we're going to name it. Real quick, if you want to pause the screen and write these down, these are the fancy words for how to name it. So number of terms, if it's got 1 term, it could be called a monomial. 2 terms, it could be called binomial. 3 terms, trinomial. 4 terms, 4-term polynomial. 5 terms, 5-term polynomial, and so on. So 6-term polynomial, 7-term polynomial, so on and so forth. For degrees, if it's the first degree, the fancy word for it is linear. Second degree is quadratic. Third degree is cubic. Fourth degree is quartic. Fifth degree is quintic. Then from then on, it goes 6th degree polynomial, 7th degree polynomial, so on and so forth. You get the point. So for this one, this is how you name it. Number of terms, 1, 2, 3. So 3 is a trinomial. So it is a trinomial and a number degree polynomial. So this is the 4th degree, which is quartic. So a trinomial quartic polynomial, which sounds funny. If you don't want to remember all the fancy names, you could also call it a 3-term 4th degree polynomial. But just know that you're going to see the words trinomial, quartic, and all of those out there. So that's what I mean when I say classify. We're going to practice plenty of that in a second. We're also going to describe end behavior. So end behavior is, if you were looking at a graph, what do the ends do? Who cares about what the middle does? What do the arrows at the ends do? So in order to do that, you have to look at 2 things. You have to look at the leading coefficient and the degree. So we're going to be working on labeling the leading coefficient and degree of each polynomial. So the leading coefficient, remember, leading coefficient is the coefficient next to the highest degree. So in this case, it would be 6. And you need to figure out if the leading coefficient is positive or negative. That's the only thing you have to identify. Okay, the leading it's positive or it's negative. For degree, you're going to look at the degree. So that's the highest degree of the function again. So in this case, it's 4. And you have to state whether it's even or odd. So now looking at whether it's positive or negative, even and odd. So positive and negative for the leading coefficient, even and odd for the degree. Don't tell me if it's even or odd for the lead coefficient. We're gonna work on labeling that in a second, but here's these notes that correspond with it. So after you figure out if the degree is even or odd, leading coefficient is positive or negative, you're going to use this chart to identify the end behavior. So there's 2 ways to do end behavior, and I want you to do both every time. You draw it with the arrows and you draw it with the fancy math symbols. So I'm going to zoom in so you can see these fancy math symbols even more. Come on, zoom better. So this is saying that f of x is going towards negative infinity as x goes towards negative infinity. So that's all right, on the x-axis, negative infinity is here. It's just fancy for saying it goes down. So as x is going to negative infinity, so as it's going to the left, it's going down. As it's going to the right, the arrow is pointing up. So that's just the fancy notation there. All of them have it. You need to get used to writing this. We're going to talk about it. But again, you're just looking at this and saying, oh, that left arrow is pointing down. That right arrow is pointing up. so on and so forth. So these are both pointing up, left and right arrow pointing up, left and right arrow pointing down. You need to know this fancy notation for that. So, ways to remember this fancy chart. Well, this whole arrow up and down thing. You can use this chart at all times. It's an easy Google, as long as, and it's right here in your notes. But note that if the lead coefficient is positive, then the second arrow goes up. If the lead coefficient is negative, the second arrow goes down. So you'll be able to write that arrow right away by looking at the lead coefficient. Then to figure out what the first arrow does, if the degree is even, both of the arrows go in the same direction. So in this case, even, both of the arrows are going in the same direction. If it's odd, both of the arrows go in opposite directions. So if this was down, then this goes up. So all of your information is right here. Right now, your information seems a little weird and you're not really understanding it. So we have to actually do examples to understand this. Before we do some examples, I do want a quick reminder that by looking at a polynomial, we can determine the maximum number of zero solutions or roots it has because it corresponds with the maximum numbers of times across the x-axis. Remember, there's our 4 synonyms. But by looking at the polynomial, we can figure out this. All you have to do is look at the degree. So that degree is going to tell us the number of zero solutions, roots, and x-intercepts we have. So we're going to list that in our characteristics as we go on. So I'm going to normally just hand you a polynomial and say, all right, do me a favor, list the end behavior, state the number of solutions. So this is how you're going to set up each problem if I've ever asked you this and for all the problems that you're going to do today. So first you're going to start by the lead coefficient, writing if it's positive or negative. So in this case, the lead coefficient is -1. That lead coefficient itself is negative. Then you're going to look at the degree of the polynomial. The degree is 5. 5 is an odd number. So now, like I said, the lead coefficient is going to tell you what your second arrow does. So that means the second arrow is going to go negative. The degree is going to tell you what the first one does. If it's odd, it's going to go in the opposite direction. If it's even, it's going to go in the same. So odd, opposite. Now again, if you don't want to memorize this, you just see negative and odd. You're going to flip back to this table. You're going to look for negative and odd, and see, okay, this is it right there, which is exactly what I drew right here. And then you're going to have to write the behavior in mathematic terms. So again, this consists of just memorizing and writing it down, or you can think through it logically by saying, okay, so the right arrow, or I meant the left arrow, so left is x approaches -infinity, goes up. So goes up is f of x, goes up, goes to positive infinity. Right, you write right as x approaches positive infinity, right, on the right. And that one's going down, so it goes to negative infinity. Remember, left or right, up or down. Left or right, up or down. Last thing we're going to do is we're going to practice classifying this. So this is a one term. So one term is monomial. And its degree is 5, so it's a monomial to the 5th degree, which we said was called quintic polynomial. So now we can list all these things, so it's right there. All right, we're going to do another one. Let's look at number 2. We're going to do the end behavior, we're going to do the number of solutions, we're even going to name it. So the leading coefficient is 1. 1 is a positive number. Degree is 4. 4 is even. So positive means the second arrow is going up. Even means both of the arrows are going in the same direction. Again, refer to your table if you don't feel like thinking about this. So my left arrow, this is how you write left arrow. This is how you write right arrow. My left arrow is going up. This is how you write up. My right arrow is going up as well. This is how you write up. Again, this is just right in the table. This has 2 terms, so it's a binomial. And the highest degree is 4, so it's a binomial quartic polynomial. All right, we're going to try 3. So again, lead coefficient. The lead coefficient's all the way over here. Lead coefficient is -2. That's a negative. The degree is 3. That's an odd number. Negative second arrow down, odd opposite. Again, just refer to the table if you didn't feel like thinking about it. So I have to know what's going on with my right arrow. I have to know what's going on with my left arrow. My right arrow, or I meant my left arrow than my right arrow. My left arrow is going up. So I'm going to write up in my fancy math terms. My second arrow is going down, so I'm going to write down with my fancy math terms. And again, if you don't understand what I'm saying, the table has this written. You're just copying it from the table. This has 1, 2, 3, 4 terms. So it is a 4-term. Highest degree is 3 cubic polynomial. All right, now we're going to look at 4, 5, and 6. So number 4, lead coefficient is 3. That's positive. Degree is also 3. That's odd. So positive means second arrow goes up. Odd means goes opposite direction. I need to see what my left arrow does. That means left arrow. I need to see what my right arrow does. That means right arrow. My left arrow is going down. This means down. My right arrow is going up. This means up. It has 1, 2, 3, 4 terms. So that's going to be a 4-term. Highest degree is 3 cubic polynomial. Then we have 5, so our lead coefficient is -1, that's negative. Our degree is 4, that's even. That means my second arrow is going down. Even means they're both going in the same direction. I need to figure out what my left arrow is doing. I need to figure out what my right arrow is doing. Both arrows are going down, so I'm going to write down in my math language. And again, this all comes from the table. 1, 2, 3, 3 terms, so that's a trinomial. One highest degree is 4, so that's a quartic polynomial. So it's a trinomial quartic, quartic trinomial, whatever order sounds better for these weird ones. This last one, we have our lead coefficient being 2. 2 is a positive number. Our highest degree is 3. 3 is a odd number. Positive means second arrow goes up. Odd means they're going in the opposite direction. So that means now I need to write what my left arrow is doing, what my right arrow is doing. My left arrow is going down, so I'm writing down. in my fancy math notation, my right arrow is going up, so I'm writing goes up in my fancy math notation. 1, 2, that's a binomial. And the highest degree is 3, so it's a cubic binomial, cubic, whatever you want to write there. The last thing we have to go through and do is state the number of solutions. So remember, stating the number of solutions only comes from the degree. So number of solutions is 5. Number of solutions is 4. Number of solutions is 3. Number of solutions is 3. Number of solutions is 4. Number of solutions is 3. Just writing down that degree all over again. So to summarize, here's a little practice. If you understand behavior, you would understand which equation of these goes to the roller coaster. So take a second and take a guess. All right, let's reflect on what we said. Well, remember to figure out the end behavior. This obviously has our left arrow going down, our right arrow going up. So that means if our right arrow is going up, our lead coefficient had to be positive. And if they're going in opposite directions, our degree had to be odd. So looking at both of these options, both of them are odd degrees, okay? So we need our lead coefficient to be positive. A, lead coefficient positive. Now you're going to go on and you are going to complete a bunch of problems to practice naming all these things. Make sure that you answer everything specified on the worksheet.